Hello, today we discuss about Java Applet. So Java Applet provide us a GUI, that is called graphical user interface. Let me brief about what is graphical user interface. So it is a nothing but a easy way of user interaction. Previously, we have developed some applications in Java which is console based. So in Java we have two types of application. One is console based application and other is graphical user interface. So in console based applications we give commands to the program so that the program will works. In graphical user interface the command would be provided by some graphical constructs which is uh, called components and containers. So Java provides a rich family of components and containers to make a GUI effective and efficient. So GUI is nothing but a medium between a programmer and a user, and which will make a user to give the interaction in more easy way. So there are various advantages of GUI. First is it is a user friendly because user have just click on some buttons, just enter the data in the text fields. Everything is previously designed and user just have to put the information on those designed components. Secondly, it add beauty to the interaction. It add pictures, colors, animation, and various types of menus can be added. Third, it creates some graphical components like buttons, checkboxes, etc. These components will be provided by a package called java.awt package. So we have Java AWT, that is called Abstract Window Toolkit, for making of GUI applications in Java. I provide some brief of the class hierarchy in java.awt package. As we know, the superclass of all classes is the object class in Java. So every class hierarchy we have a tree type of structure in which the root is the object class. So in case of AWT package, we have component, different types of components are available. These components have subclasses like label, button, checkbox. So these classes can be instantiated whenever its use is there. So like for example, if you want to create a label, then you can instantiate the object of label class. Similarly for button, checkbox, list, choice, scroll bar, canvas, text component, window, and dialog. There are further subclasses of text component, that is text area and text field. There is a subclass of window class, that is a frame, and there is a subclass of dialog class, that is a file dialog. This window, frame, panel, and applet are the subclasses of containers. So containers are the area on which we have to put the components. So for example, we can treat container as a plain paper, and we can treat component as objects drawn on that plain paper. So first we have to build a container, then on that container we have to add some components in order to make a GUI application. So some what is a component in AWT? So component is a super class of all Java components and is declared as a abstract class. So let's see the signature of a component class. So as we see that this component is an abstract class with a public access. It extends the object class and implements some image observer, menu container, and serializable classes. These these component class have different properties like the object is displayed on the container. As I told you earlier, you think a container as a plain paper on which components are added. So what is component? Component is a object graphically displayed on the container. A container may be a frame, maybe a applet for user interaction. Any subclass of component class is called component. So any subclass of the component class, like button is a subclass of component class, so we call this button as a component. Now some important method of the components. First is set enabled method. So if we call this method set enabled with the value true and false, it will enable or disable my component on my container. So if I call like button b1 dot set enabled true, it means that that button is visible on my container. And if I make it false, that means that button is not visible on my container. Second is set bounds. Set bounds is used to set the position of the component on the container. So however, this set bound method is not used so much because generally we use layout manager to display the component on the container. If you want your manual coordinates, then we can set using the set bounds methods. We can access the width on the of the component using getWidth method. We can also access the height using getHeight method. Paint method is used to display anything on the component or a container. Repaint method is again initialize the container and display the data which is passed inside this method. Now move to the applet. So applet is a subclass of a container class. So we can think a applet as a plain paper on which we have to put some components. So generally, what is the meaning of applet and why this applet is come into picture? So we try to understand this concept. Now, as we see in this diagram, applet is nothing but a Java bytecode plus HTML page. So what is a in this statement itself tells you the need of applet. So here HTML means hypertext markup language. So HTML language is used to build a HTML pages. So it is a markup language. It is not a programming language. So in earlier time, when the web pages are introduced, those web pages are only contain a static information. Those web pages are not having a dynamic contents. So if we want any dynamic content on these web pages, dynamic content means suppose on a HTML page you have some kind of tables, you have some kind of text information, you have some kind of images. So these are all kind of static things are there in your HTML page. Suppose on a particular moment of time you want some calculation on your HTML page. Suppose I want that if I give some input 2 and 2, then the addition of those two numbers would be displayed on your web browser. So this type of content is called a dynamic content in which you have to perform some functionality. Because HTML is a markup language, so markup language does not provide you functions, so you cannot implement any type of functionality in your web page. So to include functionality or to include some dynamic behavior on the web page, we introduced applet inside your HTML page, and this applet can be included by the tags. So let me brief you what is tags and markup languages. So you can understand the markup languages as a language which is a collection of tags. So for a particular static type of data, we define some tags. In HTML we have defined some title tag, some body tag, some header tag. So if I have some title tag, for example in this let me show you an example of a HTML code. So this is my HTML code in which this is a HTML title. So if I say that this HTML tag is there, it means it is a beginning of my web browser. It will tell the web browser that your HTML content will be start from here. Then second option is a title. So the web browser is entitled as applet in browser. The third option will be the body option, in which the main content would be there. Now in body option I include an applet tag. It means some dynamic information would be included here in form of bytecode. This applet1.class is a bytecode of some functionality. So this functionality is now embedded in my web page. So what is applet? Applet is nothing but a Java bytecode plus HTML page. So here we have an HTML page with the dynamic content by the help of Java applet. So this dynamic content can also be downloaded from some server. So by the applet we can also implement some client server architecture, in which web browser requests some type of function from the server, and the server will pass the bytecode to the client, and the bytecode is executed on the web browser. So your applet codes are run on the web browser by your JRE machine or JVM environment. Because the bytecode is transferred and Java is portable, we can execute that bytecode on our local machine by some plugins embedded in the browser. So for the applet, we can run those applet by the browser itself, or Java itself provide an software that is called Applet Viewer to run this type of applications. Now let us discuss about the life cycle of an applet. So applet have different stages. Begin with init method. Then in init method, it is like a constructor in your Java program. So in this method we initialize all the components of the applet, and we can also provide some values to those components. Then we have a start method, in which their applet is start running. Then we have a stop method. If at any moment of time you want to pause your applet execution, then you call this method, that is called stop. And to free the memory of applet, you call the destroy method. So these four methods are there. Here we have to understand the difference between these stop and destroy. So the main difference between these two methods are: destroy method will deallocate the memory of an applet from the memory, while the stop method will not deallocate the memory, it just pause the execution of the applet. Now as I told you earlier, applet are executed in two ways. One is in web browser, we have included applet tag in HTML file. Another way is the applet viewer application, which is also read the applet tag, which is included in your Java source file. So we will demonstrate both of the ways of execution in by the example. So let us see how to create an applet. So for an example, I already written a program of an applet. So you can see that in this program we include java.awt.star, that is abstract window toolkit. All classes will be imported, and generally we use this graphics class of java.awt here. Then we include java.applet class. This applet class is nothing but this applet is a package in which we use the applet class. So applet class is already defined, in which we have already seen the some methods like init, start, paint and stop. So every class, if you want to create an applet, every class must be a subclass of this applet class. If it is a subclass, it means all the functionality defined in this superclass applet is automatically inherited in the subclass. Now in this example, I am trying to override those functionalities. So I am trying to override the definition of init, start, stop and paint methods. So let us see what we have done in those overridden definitions. So we take a string buffer here. Initially we take a string buffer. So this string buffer is initialized with a string hello. Now you override the init method by append the string buffer with another string called init. Then in start method I just again append the string buffer, and the appended string will be start. In paint method I just print this appended string by the method g.drawString. So graphics class is used to uh, print something on the applet. So if you want to write something on the applet without adding any component, then it is a way. You use the reference of a graphics class, and by that reference you call the drawString method of this graphics class. So by this method I can directly print any text string information on my applet container. Then we override the stop method, in which I append the stop string to the string buffer. Then destroy method is there, in which destroy will be appended to the string buffer, and a statement system.out.println will be printed on the console. Because after destroy we cannot see the output on the applet, so I just print the output on the console. So let us see how to run this program. So let me clear this screen. Sorry. So to run this program, first go to the path where your Java source file is there. In my case, I have stored this file on java.applet on my desktop. So go to desktop and compile with Java C Java applet1, that is my file name .java. Once you compile the program, a .class file is generated. So you can also see the .class file here. A .class file generated. So to run the applet, we are not using the interpreter which is known as Java, because this interpreter Java requires a main method, and as you see in your applet program, main method is not there. So there is a special interpreter for this applets, and which is called applet viewer. So this applet viewer will pass is executed by passing an argument applet1.java. The source file itself we pass into the applet viewer. Why we pass the source file itself? Because it is already compiled. As it is already compiled, it does not have to require this source file. So applet viewer does not look for the source file here. It will look for the applet tag, because after execution of Java source file of an applet, a bytecode would be generated. Now as we see in your slide, that applet is nothing but a bytecode plus HTML. So we need some tag information in order to execute the applet. So that tag information is provided in the comment section here in my Java source file. I highlighted this one. In the comment section I use an applet tag in which I provide a value to attribute code, and the value would be applet1.class. So the whole source file will be ignored by the applet viewer. Only the comment section will be highlighted, and only the comment section will be read by applet viewer. So in the comment section, applet1.class is find out, and the height and width attributes are given. So an applet with height 500 and width 500 should be generated after executing this code. So I just execute this code on my command prompt, applet viewer applet1.java. So I parse this source file. In this source file, only these two lines would be read by applet viewer. So I just enter. After enter, you can see that applet viewer, a applet window is generated with minimize and resize and maximize button. Resize and close button. Now this applet have a message hello. So because in applet life cycle, we study the applet life cycle. Whenever a applet is generated, it automatically calls init and start function. So by the outcome, you can see that already init and start function is called. So after init and start, a paint function is called. This is the order in which the applet functions are executed. So you can see the order. That's why we are overriding those functions to see the order, how the applet functions are executed. So we can see that we have a string buffer hello. So let me show you again. In our example, we have a string buffer in which hello string is there. So sb contain a hello, it will call the init method. Init string is appended to sb, then it will call the start method. Start is appended to sb, then this paint method is called, in which these three string which is appended to one string buffer would be displayed. Now we have to check the order of stop and destroy methods now, because we already see the order of init, start and paint method. So because you can see that my command prompt is not stopped here, it means applet is running. A start to paint, applet is running. So if I minimize this window and again maximize, then you can see that a string stop and start is appended. It means whenever you minimize the window, it means applet is paused. Whenever applet is paused, a stop method is called, which will stop the execution of an applet. And because I again resize open this window, that means applet start method is called. So whenever you minimize and reopen, it means stop start method is called. So these strings are appended in a string buffer and the message is displayed. Every time start method is called, it automatically go to the paint method. So that's why in paint method we have displayed string stop start. Okay, so the order is, you whenever you initialize the applet, it will call the init method, then start paint. If you minimize, then it will call the stop, then start paint. And I again show you after minimizing and maximizing, again it will call the stop and start and paint method. Then if I close this window, by cross button, then the destroy method would be called, because then applet is the memory of this applet would be free. So I just close this window. So as you can see in this command window, all the content of string buffer would be displayed along with the destroy option. It means the destroy function is called. Now the applet is destroyed, it is free from the memory, and the command is returned to original location. Okay, now this is a one way of executing an applet. The other way, as we see in our slide, the other way of executing applet is in web browser. So in web browser we have to write the HTML file. So for this we will continue in the next lecture. Thank you, and wait for the next lecture in next video. Thank you very much for listening this video.